Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at comparing floats because there's something here which might catch you out. So this also applies to comparing doubles as well. Let's say we've got a floating point type here. Let's call it value 1 and set it equal to 1.1 like that. And then let's say if value 1 equals 1.1, then cout equals, else we're going to say, just finish typing this before I get ahead of myself, else let's say cout not equal. So does this code work? Well, let's run it and find out. So I'll run this code and we'll see. So it says not equal. So sometimes when you run this, it'll probably say equals, but in this case it's saying not equals. Why is that? Well, of course, as we've seen before, if we do cout value 1 on this float and we run this, then well, let's include iomanip here. Include iomanip, and let's get some more decimal places. Let's say set were 10 or something like that. That should be enough. So if we run this now, set precision is the one that I want. Then we see that the floating point type it can't be stored precisely. So after a certain number of digits, because there's only a limited amount of memory, after a certain number of digits, the value, what we interpret that float to be, is going to get just sort of crazy and a bit random. We can only rely on the float for a certain number of digits, a certain amount of precision. And for that reason, if you compare two floats with equals, you get unpredictable results because a float is not exactly equal to anything. It's like asking if one person in real life is the same height as another person or not. You know, for all intents and purposes, two people might be the same height, but they're never exactly the same height because we can never use infinite precision, not even in normal life, never mind programming. So you basically can't use equals to compare floating point types. If you want to compare floating point types, you can use something like this. So we know that a float will store something like 7 decimal places. Here we've got 1, 2, 3, 4, 5, 6, 7. Or I should say like 7 or 8 significant digits accurately. So therefore, if we use less than or greater than, as long as we're dealing with less than 7 or 8 significant digits, we will get the result that we expect. So we will find here that that value 1 is less than 1.111. This text is wrong now, but you get the idea. So if you want to find out if two floating point values are similar, you need to think about asking if the difference between them is less than a certain amount or not, rather than using equals to compare them. So good idea to check this on your own compiler. See if you get that these two floats are equal or not. You might do or you might not do, and try it with some other values and see if you can get a value where we see this problem occurring. Okay, so until next time, happy coding.